Hello everyone. So today I'll discuss this nice problem of Irodov. This is a very nice problem. So ये ऐसा एक प्रॉब्लम है कि आपका होश उड़ा देगा. So पहली बात है कि they have given there's a long solenoid of cross section of radius A has thin insulated wire ring. एक second. Yeah. Tightly put on its winding. One half of the ring has the resistance eta times that of the other half. The magnetic induction produced by the solenoid varies with time as B equal to small bt, where small b is a constant. Find the magnitude of electric field strength in the ring. So what is this question is talking about? So basically initially there's a solenoid, and over this solenoid there's a ring, and this ring this ring has resistance difference. So one resistance is R, another is eta times R. So resistance of upper half and lower half is different. Correct. Now they're asking when the current through the solenoid, obviously through the solenoid windings are there, current is flowing. So when current through the solenoid is changing, okay, so what will happen? It will change the magnetic field. So they have directly given magnetic field. Inside this solenoid, magnetic field induction B is changing as Bt. They're asking find the magnitude of electric field strength in the ring. So generally what a student thinks, generally a student will think that okay, I have to find magnitude of electric field. So let us apply E dot dl, close integral of E dot dl equal to d phi by dt. Correct. So if you do this, E into 2 pi a equal to d phi. D phi by dt is area pi a square, area into dB by dt. So magnetic field is a small bt. So dB by dt will be B. Okay. So here pi a square into dB by dt is B. So electric field you get pi a square B by 2 pi a. Pi cancel, a square cancel. So AB by 2. So this is induced electric field you are talking about, correct? But question here, little bit clarifying. So question here, whatever electric field they're asking, this is electrostatic field, which is conservative. Electrostatic field, static field. They're not asking about induced electric field. They're not asking about induced electric field. So this is not the answer. You can see answer is not this. So generally a student gets confused why the answer is not coming. So this is conservative field. They're asking to find conservative field. Conservative field. Okay. Now, whenever magnetic field through any space is varying, whenever magnetic field through any space is varying, okay, magnetic field is changing at some rate. So here we know that there is a induced electric field E which is non-conservative, correct? Induced electric field which is non-conservative like this, induced electric field. So in this case, there is no conservative field. Okay, so this ring is uniform. I'm assuming this ring is uniform. So whenever this ring is uniform, there is there is no electrostatic field. Electrostatic field field develops. Okay, that means conservative field. Okay, this is conservative field. Conservative field will be 0. 100% sure. Sir, how it will be 0? How you can say it is 0? Okay. We can prove this that conservative field will be 0. How we can prove this? You know that J equal to sigma E. Okay. This relation you know. Okay. So here E, what is this E? This E is E total. That means E conservative plus E non-conservative. Both. It consists of both. So I am assuming that inside there is conservative field. Okay. So what will be the direction of conservative field? J, from this relation you can understand that J is parallel to E. So direction of J and E is parallel. Okay, here because current density will be in the direction of current, no? So I know there will be if B is increasing with time. Okay, if dB by dt is increasing, dB by dt is positive, B is increasing with time, then induced current will be in the anticlockwise direction. So J will also be anticlockwise. So J will be tangential, correct? Tangential. Since J is tangential, direction of electric field is also tangential. So I have found one is non-conservative field, non-conservative electric field, which is tangential. Okay, that is induced electric field. Now, what about conservative field? Conservative field also has to be in that direction. Either it has to be in this direction tangentially, or it can be antiparallel. So E conservative, from this relation I can say 100% sure that E conservative EC must be tangential. Okay, either parallel or antiparallel. Antiparallel. Antiparallel to what? Antiparallel to the J. Understood? Because it cannot be some other direction. It's parallel or antiparallel. So if I consider that this electric field is parallel, so it's forming a closed loop, and we know, we know for conservative field, closed integral of EC dot dl equal to 0 for conservative field. Correct? So because it never forms closed loop, you know that. Conservative field, conservative electrostatic field never forms closed loop. So for a closed loop, EC dot dl will be 0. Now, if I consider the electric field as tangential, conservative field as tangential here. Now, if I go across the loop, will it be 0? No. Okay. So from here, I can write closed integral of EC dot dl equal to what? Value of EC into 2 pi r. So this has to be 0. If this has to be 0, that means EC has to be 0. Okay. If it is non-zero, then it is not possible, correct? So that means EC has to be 0. So there is no conservative field appears in this case, correct? Okay. Now for non-conservative field, potential across any 2 point. If I take potential across any 2 point, potential difference across or about any 2 point must be 0, must be 0. Okay, okay. So if potential difference is 0, because potential difference is only defined for conservative field. Okay. Now, how conservative field generates? Very basic fundamental. Conservative conservative field exists in any region because of because of charge accumulation. Charge accumulation. Okay, if there is only charge accumulation, then only conservative field will be there. Otherwise, there won't be any conservative field. Okay, so if I consider there is a non-conservative field, sorry, non-uniform ring. What happens for non-uniform ring? So if there is a non-uniform ring, so I have considered here, you can see, I have considered there is a non-uniform ring. Okay, so for this non-uniform ring, here there can be any conservative field. Okay, let us try to understand. So here, one place resistance is R, and here resistance is eta times R. Okay, so I can also say that here resistivity will be rho, and because it's symmetrical, ring is symmetrical, so here it will be eta times rho. Correct, resistance equal to rho L by A. Okay, then what is electric field? Electric field is electric field. Uh, what is J? J equal to sigma E. Correct. So here, if I consider electric field is E, so that is basically J equal to 1 by rho into E. 1 by rho into E. So if I consider in the above part, upper part of the ring, electric field is E, what will be the electric field at lower part? J equal to sigma is eta times rho into E. Correct. That means here J is constant throughout. That means here electric field is not E. It is also eta times E. So above it is, if electric field is E, below electric field will be eta times E. So now there is a change in electric field. But we know due to non-conservative field, electric field is same everywhere. Whatever non-conservative field is acting, ENC is same throughout, correct? ENC. But here the electric field for upper part is eta and electric field at lower part is eta times upper part is E and lower part is eta times E. That means there is a change in electric field. So from where this change in electric field is coming? So there must be some conservative field. There must be some conservative field. Okay, clear? So basically, I just want to say that J equal to sigma E, J equal to E by rho. So J rho equal to E. So E must be directly proportional to rho. So below part, if it is eta times rho, so electric field will be eta times E. Okay. So now I have found there is a change in electric field in upper part and lower part. Okay. Now what is this electric field is coming? We know that due to non-conservative field, non-conservative field ENC, it's same everywhere. Same everywhere. If it is same everywhere, that means there must be conservative field also in this ring. There must be conservative field. Conservative field in this ring. Okay. So I have found that there must be conservative field. Now what can be the direction of conservative field? If direction of conservative is same throughout the ring, if direction direction of EC conservative field is same throughout, is it possible that direction of conservative field is same throughout? No, not possible. Then E dot dl, close integral E dot dl won't be zero, which is again which is against the law of conservative field. Correct? So that means from here I can say direction of EC is different in upper and lower part of ring. Okay. So direction of conservative field must be different. Different means must be opposite. Basically opposite. Opposite. Here. So now I have found this. Okay. Now let us try to understand. Let us try to solve this question. Okay. I'll just copy this. Okay. So here for this given ring, what is the current? ENC is also there. You know, everywhere ENC is there. And E conservative is also there. ENC, ENC. Okay. Okay. What is current? Current. Current is EMF. EMF by resistance. Correct. Induced EMF. What is induced EMF in this? Pi A square dV by dt. d phi by dt divided by R plus eta times R. Correct? So current I can write pi A square B divided by R 1 plus eta. So this is the current. Remember this. We'll use this equation. Okay. Now, so for this, I can say that in the above direction of conservative field is this side, and where net electric field is E, and in the below the direction of conservative field is in the direction of non-conservative field. You see. So upper part, conservative field is opposing non-conservative field, and lower part, conservative field is supporting the non-conservative field. So that's why in the lower part, it is eta times C electric field. Now, from Ohm's law, I know J equal to sigma E. So, J equal to E by rho. So, I can write E equal to rho J into rho. Okay. What is J? J is I by A. What is rho? Rho is RA by L. Fine. So, this is electric field. That is equal to I R A gets cancelled IR by L. Okay. Now let us put the value of I. E equal to I is put the value of I pi A square B by R 1 plus eta. Okay, I into R by L. What is L? Pi into A. What is the electric field I am getting here? Electric field I am getting, that is AB AB by 1 plus eta. A gets cancelled, pi gets R gets 1 plus eta. So this is the electric field. Now what is E net? This is net electric field. E net equal to AB by 1 plus eta. That is equal to what? For upper part, it's opposite, correct? That is equal to E NC minus EC, correct? What is EC? EC is ENC. ENC is AB by 2 minus AB by 1 plus eta. Non-conservative field is AB by 2. I have found before. You can see here. Due to non-conservative, induced electric field is AB by 2. So, what is E conservative? From here, E conservative I am getting is equal to eta. AB you take common. AB you take common. Eta plus 1 minus 2 divided by 2, 1 plus eta. So, that is E conservative is AB by 2 eta minus 1 by eta plus 1. So this is the conservative field. Now you can find this for lower segment of the ring also. You'll get the same result. For lower segment, if I use for lower segment, okay, what I'll write? E equal to E net equal to what? ENC plus EC. For upper it is minus, for lower it will be plus. So that is equal to E net is how much? Eta times C. that is equal to ENC plus EC. Okay. So eta times E minus ENC equal to EC. What is this EC? So EC is eta times E. Eta times E. What is E? AB by 1 plus eta minus AB by 2. Okay. So you take AB outside. AB you take outside. You get you get 2 into 1 plus eta 2 eta minus 1 plus eta. If you solve this, you get AB by 2 eta minus 1 by eta plus 1. So this is the conservative field. I hope you understood. This is a very good problem. Okay. Please go through it once. Okay. This concept is really good concept. It will take little time to digest. Okay. Thank you very much.